Namaste, and welcome back to JEE Physics with Typical Monk. This is class 19, Magnetism and Matter. Every bar magnet is a dipole, and the whole Earth is one too. Its invisible field tilting a compass and dipping a needle. Push a field into iron, and the atoms line up, then stubbornly stay aligned even after you let go. Today we read the magnet and the planet, the dip of Earth's field, the classes of magnetic matter, and the memory written into a hysteresis loop, one idea at a time. Here is what you will learn today. First, the bar magnet as a dipole. Second, Earth's magnetism, declination, dip, and the horizontal component. Third, Magnetisation, magnetic intensity, susceptibility, and permeability. Fourth, diamagnetism, paramagnetism, and ferromagnetism. And fifth, the hysteresis loop, plus the drills, one idea at a time. 4 ideas. Run this entire chapter. Look at them together first. The magnetic dipole. A bar magnet carries a magnetic moment m, and its field is the exact mirror of an electric dipole's. Earth's field. It has a horizontal component and a vertical component, and the dip angle is what links the two. Magnetisation. M equals GH, the induced moment per unit volume, and the total field is B equals mu naught times bracket H plus M. The 3 classes, diamagnetic, paramagnetic, and ferromagnetic, set apart by the sign and the size of the susceptibility She. Now look at the picture, the memory of a ferromagnet, its hysteresis loop. The hysteresis loop. Plot B against H for a ferromagnet, and the return path lags behind the rise. The material remembers where it has been. Saturation. As H grows, B climbs to a maximum, its saturation value. At that point, all the magnetic domains are aligned. Retentivity. Now remove H, and B does not vanish. The leftover value, Br, is the magnetism the material has retained. Coercivity. Reverse H tar until B falls all the way to 0. That reverse field, H tar, is the coercivity. Now the working formulas, the ones the exam turns into marks. The ribbon holds the anchors, the field, the magnetization, and the dip. Magnetisation. M equals GH, the induced magnetic moment per unit volume, and G is the magnetic susceptibility. The relation B equals mu naught times bracket H plus M, which is mu naught times bracket 1 plus G times H, that is mu naught mu R H, and mu R equal to 1 plus G is the relative permeability. Earth's components. B horizontal equals B Earth cosine delta, B vertical equals B Earth sine delta, and tan delta equals B vertical over B horizontal. The classes. Diamagnetic, Chi small and negative, paramagnetic, small and positive, ferromagnetic, large and positive. Let us work the G favorite, Earth's field components. At a place, the horizontal component is 0.34 Gauss, and the angle of dip is 30 degrees. Find the total field and the vertical component. The data. The horizontal component B horizontal is 0.34 Gauss, and the dip angle delta is 30 degrees. The total field, B Earth equals B horizontal over cosine delta. That is 0.34 over cosine 30 degrees. Compute. Cosine 30 degrees is 0.866, so B Earth equals 0.34 over 0.866, about 0.39 Gauss. The vertical component, B vertical equals B horizontal times tan delta, 0.34 times tan 30 degrees, which is 0.34 times 0.577, about 0.2 Gauss. So the answer, the total field is about 0.39 Gauss, and the vertical component about 0.2 Gauss. And always, B Earth squared equals B horizontal squared plus B vertical squared. Now the picture behind it, the tilt of Earth's field, resolved into its components. The dip angle, delta, is the angle that the total field, B Earth, makes below the horizontal at a place. The horizontal component, B horizontal equals B Earth cosine delta. and a freely pivoted compass needle aligns itself with this. The vertical component, B vertical equals B Earth sine delta, and a dip needle, free to swing in a vertical plane, reveals it. And the link, tan delta equals B vertical over B horizontal. At the magnetic equator, the dip is 0, and at the magnetic poles, it is 90 degrees. Now what JEE actually asks, 5 pointers. 1. B equals mu naught times bracket H plus M equals chi hai, and the relative permeability mu R equals 1 plus chi hai. 2. Diamagnetic, chi small and negative, repelled, paramagnetic, small and positive, weakly attracted, ferromagnetic, large and positive. 3. Earth B horizontal equals B Earth cosine delta, B vertical equals B Earth sine delta, and tan delta equals B vertical over B horizontal. 4. Hysteresis, retentivity, the B left at H equal to 0, and coercivity, the reverse H that brings B back to 0. And 5. Soft iron, low retentivity and low coercivity for electromagnets, steel, high in both for permanent magnets. Now an assertion and reason drill. For each pair, are both true, and does the reason explain the assertion? First pair. Assertion: a diamagnetic material is repelled by a magnetic field. Reason: its magnetic susceptibility is small and negative. Both are true, and the reason directly explains the assertion. A negative susceptibility is exactly what produces the repulsion. The answer is A. Second pair. Assertion: the angle of dip at the magnetic equator is 90 degrees. Reason: the Earth's magnetic field is horizontal at the equator. The reason is true, but the assertion is false. A horizontal field means the dip is 0 at the equator, not 90. The answer is D. Third pair. Assertion: soft iron is used to make electromagnets. Reason: iron is a ferromagnetic material. Both are true. But soft iron is chosen for its low retentivity and low coercivity, not merely because it is ferromagnetic. So the reason does not explain the assertion. The answer is B. Now match each quantity to its formula. The magnetization goes to chi hai. The relative permeability goes to 1 plus chi. The dip relation goes to tan delta equals B vertical over B horizontal. And diamagnetic goes to chi less than 0. 4 pairs, each worth committing to memory. Now, how many of these 3 statements are correct? 1. A paramagnetic material has a small positive susceptibility. That is correct. 2. The angle of dip is 90 degrees at the magnetic equator. That is wrong. It is 0 at the equator. 3. Retentivity is the magnetism left when H is reduced to 0. That is correct. So the answer 2 are correct. Statements 1 and 3. The chap is statement 2. The angle of dip is 0 at the magnetic equator, not 90. Now the 2 mistakes that quietly cost marks. The myth: the angle of dip is 90 degrees at the equator and 0 at the poles. The truth: it is exactly the opposite. 0 at the magnetic equator, where the field is horizontal, and 90 degrees at the poles, where the field is vertical. The second myth: retentivity and coercivity are the same thing. The truth: retentivity is the leftover B when H equals 0, while coercivity is the reverse H that is needed to bring B back to 0. Now, test yourself. Answer in your head before the reveal. That is how JEE speed is built. Here we go. Question 1. The susceptibility of a diamagnet: small and negative. Question 2. The relative permeability in terms of chi: 1 plus chi. Question 3. The angle of dip at the magnetic equator: 0 degrees. Question 4. Tan delta equals B vertical over B horizontal. And question 5. The B left at H equal to 0 is called the retentivity. Let us gather it all in one breath. B equals ma naught times bracket H plus M, N equals chi H, and mu R equals 1 plus chi. Diamagnetic: chi less than 0, paramagnetic: Chi small and positive. Ferromagnetic, Chi large and positive. Earth, B horizontal equals B Earth cosine delta, B vertical equals B Earth sine delta, and tan delta equals B vertical over B horizontal. Hysteresis, retentivity PR, coercivity HC, and the loop area is the energy lost per cycle. Soft iron, low in both, for an electromagnet. Steel, high in both, for a permanent magnet. Next class, electromagnetic induction, Faraday's and Lenz's laws. From the dipole in a bar magnet to the tilt of the whole planet's field, magnetism in matter is a story of alignment. Atoms that turn with the field, an iron that remembers it long after. Sarah, David, Lisa, and John all began exactly where you are sitting now. One idea at a time, you will crack G. I will see you in the next class.